Good morning and hello everyone. We are Group 29 from the College of Engineering UiTM Shah Alam. So, here are the group members whose contributions led to the success of this group project assignment. Today, we are presenting our safety performance assessment of a 1 kilometer road section within our campus, stretching from Jalan Pintar 1/21A to the intersection near Jalan Tegas 1/15. This road is a primary campus artery, experiencing heavy traffic from staff and students, especially during peak lecture hours. Our objective was to evaluate the safety conditions using the International Road Assessment Program, which is IRAP framework in collaboration with the Public Works Department, JKR. By identifying hazard and performing engineering analysis, we aim to propose sustainable improvement that align with SDG 9 for resilient infrastructure and SDG 11 for safe, accessible communities. Next, how do we ensure our roads are built for safety? At all, it's about the process. It starts on the ground with field observation, identifying real-world hazard through active on-site inspection. Next, we translate the data into action by coding hazard using the global IRAP standard for objective safety ratings. We then provide actionable recommendation for improvement, concluding the comprehensive report to drive change. Practically step for a safer journey. That's our methodology.
To observe the safety analysis, we divided the 1 kilometer road into 10 segments of 100 meters each. In each segment, we recorded road features such as lane configurations, roadside hazard, lighting, and traffic control devices. Our field observation revealed several recurring issues. First, segment from 0 meter to 100 meter. This segment suffered from poor road lines and a complete lack of road length. Next, segment 100 meter until 500 meter. This segment shows significant pavement distress, including potholes and broken or missing dash line on the road. And lastly, from segments 600 meter to 1000 meters. These segments were characterized by narrow road width, a lack of zebra crossing, and insufficient pedestrian walkways.
Using the IRAP framework, we categorize these hazards into specific attributes. First is the shortage of pedestrian facilities, particularly in segments 600 meters to 900 meters. Without continuous footpaths, students are forced to walk on the carriageway, exposing them to direct traffic. IRAP research confirms that roads without facilities in high activity areas face significantly higher risks of fatal crashes. Next is road surface condition. We found potholes and uneven pavement in segments such as 0 meter to 200 meters and 800 meters to 1000 meters. This is critical for motorcyclists, as degraded surfaces increase the likelihood of skidding and loss of control crashes, typically resulting in a low 1 to 2 star safety rating. Visibility is another major concern. In segment 0 meter to 100 meter, there is a total absence of street lighting. Poor lighting reduces hazards detection time and significantly increase nighttime crash rates for pedestrians and motorcyclists.
Additionally, the absence of road markings in segment 0 to 100 meter and 400 to 600 meter means drivers lack visual guidance for lane boundaries. This increases the risk of head-on or side-swept collisions, especially during rain. Finally, we noted a lack of speed management in segment 100 to 200 meter and 700 to 800 meter. Without speed limit signs or physical calming measures like bumps, drivers are more likely to exceed safe speeds, raising the severity of any potential impact.
Then, we are currently evaluating a critical safety concern regarding narrow road width and improper parking along specific segments of our infrastructure. The primary area of concern are the segment involved from 800 meters to 900 meters and 900 meters to 1000 meters. Under the IRAP methodology, these conditions are classified as Code 1 for both lane width and roadside activity attributes. Assessments show this factor typically result in much lower star rating for road safety. The current layout increases the likelihood of side swipe collision and run-off road crashes. Narrow lanes and roadside activity constrain effective road width, obstruct sight distance, and lead to unpredictable vehicle movement. To enhance overall safety, we must provide adequate parking facilities and improve lane width where feasible to reduce these conflicts.
Based on our analysis and Jabatan Kerja Raya JKR standards, we propose the following targeted engineering solutions. First, pedestrian safety. Install continuous 1.5 to 2 meter wide raised walkways in segments 600 to 900 meter strip to provide a physical barrier from vehicles. Second, pavement rehabilitation. Perform comprehensive resurfacing in segments with potholes to restore skid resistance and stability. Third, delineation. Apply high visibility thermoplastic markings for center lines and edge lines to improve lane discipline. Fourth, lighting. Install modern LED street lighting in the initial segments to enhance nighttime security.
In addition, safety and efficiency start with how we design our street. But as our community grows, our current roads often struggle to keep up. To address this, we are prioritizing road widening wherever feasible. By meeting standard lane width, we ensure smoother traffic flow for everyone. It's not just about more space, it's about smarter space. This includes the implementation of clearly designated parking zones, so the main thoroughfare stays clear. Crucially, we are establishing strict no parking zone in high-risk area to protecting vital infrastructure and ensuring visibility where it matters most. Widening road and proper parking, building a safer and more accessible neighborhood for us all. Let's move forward together.
And lastly, speed control. To implement speed bumps and clear signage to enforce the safe system approach within campus. All in all, in conclusion, our study identified that several sections of this 1 kilometer road do not comply with GKR standards regarding surface quality, lighting, and pedestrian safety. By implementing these proposed improvements, we can create a safer, more sustainable road system that protects all campus users. This project has provided us with essential hands-on experience in solving real-world infrastructure problems using the CDIO approach, reinforcing our responsibility as future engineers to prioritize public safety.
Overall, this group project study gave civil engineering students valuable hands-on experience in addressing real-world problems using the CDIO approach. It also reinforced the idea that engineers have professional responsibility to prioritize public safety through proactive infrastructure management. That's all from us. Thank you for enjoy our video and hope you guys get something new to learn.